This is 6.6, function operations. This is part one of 3 parts that we're going to look at. Okay, the first part here, objective here, we're going to add and subtract functions. Okay, this is not going to be anything that's really new for you. Okay, this is pretty much something that you've done in the past. It's just, again, we've talked about function notation, and it's a fancy way to write equations, and essentially that's what we're going to end up doing here. Okay, so in this section, in section 6.6 function operations, we're going to look at adding and subtracting. So we're going to look at these 2 groups. Okay, so we're going to take 2 functions, an f function, a g function. We're going to add them together. We're going to take an f function, a g function. We're going to subtract them from each other. Okay. In this case, we're also going to have to figure out, okay, what numbers can we put in for x? In other words, we're going to have to be able to calculate a domain. Okay. Now, the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Okay. Also, the domain of the quotient function does not contain any x value for which the g of x is equal to 0. And we're going to talk about that in terms of domain. We've talked about domain and range and what, those kind of things. We're going to talk about it now in terms of functions. What numbers can you put in for x, and what numbers can you not put in for x? There's really, when it talks about domain and range, there's really only 2 stipulations. Okay, so let's talk about how are we going to add or subtract functions. First, to add functions, it's pretty simple. You're just going to combine all your like terms with addition. Take the 2 functions, add them together, combine your like terms, done. For subtraction, there's one thing that's a little bit different. Okay, you're going to put the second function in parentheses, so that means you're going to need to distribute the negative, and then you're going to combine your like terms. Okay. Now, in terms of identifying domain, for identifying domain, again, what number can you put in for x? When you add or subtract, your domain will be all real numbers. You can put in whatever you want, unless you have one of these 2 things. You have a square root in the problem, okay, or you have a fraction. Now, underneath a square root, if you think about it, what numbers cannot be underneath a square root? Well, in that case, it's negative numbers. So what you're going to do, if you happen to have a square root in your equation with a variable underneath of it, you're going to take what's inside the square root, what's underneath that square root, set it greater than or equal to 0, and then solve the equation. Okay? Now, when you solve the equation, that's the number that's going to make whatever's underneath that square root negative. Okay? And we can't have a negative underneath the square root. Now, the other stipulation, the second one is if the variable is in the denominator of a fraction. Remember, we cannot have 0 in the denominator of a fraction. So in that case, if there's a variable down there, we're going to set the denominator not equal to 0 and then solve it as well, and that will tell us what x cannot be. Okay, now let's go back here to the top of the page, and I want you to look at the notation. There's 2 ways here that you can write the notation of adding or subtracting functions. Most of the time you're going to see it this way, but they will also do it this way as well. You'll see it both ways. They essentially mean you're going to take the function f minus the function g, the function f plus the function g, or it could be flip-flopped around depending on what they want you to find. Okay, so now let's take a look at some examples. Okay, number 1 says let f of x equal 2x squared plus 8 and g of x equals x minus 3. What are f of x plus g of x and f of x minus g of x? So, f of x plus g of x. We're going to put that over here on the left. F of x is 2x squared plus 8, and we're going to add that to g of x, which is x minus 3. Okay? Now, once you get to that point, you've put your 2 functions together, we're going to combine our like terms. So 2x squared doesn't have anything, x doesn't have anything, and 8 minus 3 is positive 5. Now, the last part that you'll need to do is what we call the domain. Again, the two things you're looking for. Are there any fractions in our problem, and are there any square roots? If there are not, then your domain is all real numbers. You can put in whatever number you want in for x. Now, the symbol for that is two lines like that. That's the symbol for all real numbers. You'll see me do that here later. Okay? So, next time we want to find f of x minus g of x. Now, don't forget with subtraction, we're going to distribute a negative. So we have f of x, 2x squared plus 8, minus g of x is x minus 3. We always put the second one in parentheses. And I'm going to distribute the negative first. So I've got 2x squared plus 8 minus x and plus 3. Again, combine my like terms, 2x squared. I've got a minus x and a plus 11. Again, for my domain, what numbers can I put in for x? Again, are there any square roots or are there any fractions? No, there's not. So my domain is all real numbers. Okay, let's take a look at number 2. F of x is 3x plus 2. G of x is 2x squared. So we want to find f of x plus g of x. So I take f of x is 3x plus 2 plus g of x is 2x squared. Are there any like terms to combine? No, there's not. Now, one thing that they'll do a lot of times is they'll rearrange it in terms of powers. So go from highest power to lowest power. So in this case, they might do 2x squared plus 3x plus 2. Got to figure out the domain. Are there any square roots or fractions? No, there's not. So my domain is all reals. I can put in whatever number I want. Okay, next one is g of x minus f of x. So we got to be careful. G of x is 2x squared. Minus f of x is 3x plus 2. Again, got to distribute the negative. So this is 2x squared minus 3x and minus 2. Okay, and again, my domain in this case, there's no fractions, no decimal, or no fractions and no square roots, so my domain is all real numbers. Okay, let's take a look at this last example now. Again, we're going to add the two functions, f of x plus g of x. As we look at this, I take f of x is 4x plus 7, plus g of x is the square root of x plus x. And now I'm going to combine my like terms. I've got 5x, I've got the square root of x, and I've got 7. Now, domain. I don't have any other like terms to combine, so now I look at my domain. My domain, are there any fractions? No. Is there a square root? Yes, there is. So on the square root, I take whatever's underneath the square root, and I have to set it equal greater than or equal to 0, because it can't be less than 0. That's a negative number. That means it can't be negative. Okay? So, as you look at this, in this case, x has to be greater than or equal to 0 in order for this to be a function. Okay? All right, let's take a look at f of x now minus g of x. So f of x is 4x plus 7 minus g of x is the square root of x plus x. Distribute the negative. So 4x plus 7 minus the square root of x minus x. And 4x minus x is 3x minus the square root of x plus 7. Again, domain. Do I have a fraction? No. Do I have a square root? I sure do. Again, right here is what's underneath the square root. Take what underneath the square root, set it greater than or equal to 0. Okay? So, I went through some examples where we're adding and subtracting functions. I've given you an example of a different domain. Most domains are going to be all real numbers, but again, it is all predicated on whether it's a fraction or a square root. Okay, this concludes 6.6 part 1. Don't forget to complete your WSQ.